Now that we know about these 4 design patterns, POM, factory, method, facade, and singleton, it's time to see them in action in the automation framework that will be demonstrated. As a note, this demonstration is using Java, but other than that, other than some implementation details, design patterns have nothing to do with the language used, except that they need to be object-oriented languages, as we mentioned. Since this simple demonstrations focuses on automated testing for a web application, we'll see how each page functionality and objects are organized in their own classes using POM. We'll see how driver, factory, facade class is initializing drivers for each test that needs to be run in parallel, and also controls what functionality is exposed to the user using factory and facade patterns. And we'll also demonstrate a singleton pattern by using the thread local class in making sure that tests can be run in parallel. We picked as tools Cucumber as a behavior-driven development framework, Selenium, and TestNG as mentioned in the prerequisites that I hope you all saw. As a high-level overview, at the core of the behavior-driven development frameworks, in short BDD, is the given, when, then approach. So given some context, which represents the precondition of the test, when some action is performed, actions that are needed to perform the use cases, then particular outcome consequences of the above steps, results are asserted. There are other BDD frameworks out there outside Cucumber, like PyTest BDD and Behave for Python, JBehave for Java, and so on. And I think it may be worth exploring them. While BDD creates quite a bit of controversy around them, the BDD frameworks help in presenting the use case tested in almost English-like form. So theoretically, business owners, PM, should be able to understand what the framework is testing, and in some cases contribute to the testing coverage. To add, the purpose of this demonstration, for the purpose of this demonstration, having deep knowledge about these tools is not required, but they are used quite a lot out there, so knowing them or about them is recommended. But don't worry too much. I think it'll be easy to understand our example as you will see it being demonstrated. Okay, so the purpose of this framework is to demonstrate basic flow for you all to understand how we can implement design patterns in a UI-based framework. Why UI-based, as we discussed before, is that in this case, POM can be covered as well. This test framework is a basic one that leverages open sources tools, technologies like Java, Selenium, WebDriver, Selenium WebDriver, Cucumber TestNG, Maven, Cucumber reporting, but we are not restricting you to use these tools and technologies. Each feature is tested in parallel during the end-to-end testing. Basic validations are incorporated for each flow. Also, the framework is capable of generating a report for the examples, a report for the results. As use cases, we basically pick a random website, aspiration.com, this one. But in your assignment, you can use the same website or pick another random website to automate. We'll talk more about this website as we go. So design patterns demonstrated in the framework are the same ones that we covered so far, explicitly page object model, factory pattern, facade pattern, and singleton pattern. So what we'll be testing as part of this? So starting with the homepage validation. Can you all see my screen with the aspiration website open? Can you raise your hand and confirm? Okay, perfect. Thank you. So we will navigate to the homepage, verify that we are successfully landed on the page, as you can see right here. Next, when navigating down, you will see that the homepage has 2 cards, Aspiration and Aspiration Plus. As our next use case, we'll be clicking on the Aspiration card as an unsigned user and verify that the user is able to see the modal view right here for an email address to sign up that is expected to open respected to open for an unsigned user. It looks like you don't have right to talk. Let me allow it. Okay. After the aspiration card, we'll move to the aspiration plus. The same as in the previous case, the user is able to see the model view when he clicks on the card, and enter an email address to sign up. So these are just basic use cases to kind of give you an idea of how the UI testing framework can be organized. We will also cover some use cases for the spend and save page. Let's see. Do you all see my spend and save button over here? Please raise your hand if you see it. Okay, perfect. At first, you will be testing that if you click on the menu button spend and save, like so, you land on the spend and save page, and we'll be asserting for the string the account built for the planet to make sure we are on the spend and save page. But we'll be covering this later looking at the code. Also, we'll be validating that the user can see the 2 plan cards. Just go to them right here. And that the plan contains the expected costs associated with each card, like 0 in case of aspiration and $7.99 in case of aspiration plus. Okay, so next, let's look. Oh, any questions on the use cases that we'll cover? Okay, so next, let's look at the high-level view of the framework structure. In this case, this is a Maven project, and in most Maven projects, independently of what language you are using, the structure will have source, main, and test. Under main and test folder, you will have a Java folder. In the case of Java, as in here. And usually, resources folder, in general, the resource folder is meant to store all your project's resources, like XML files, images, text files, and so on. But in our case, we will not be using it. As part of the source main Java, you see we have the base package containing a library that implements the factory and facade design patterns. And you'll see as we move forward, we'll look close at the code for this. And also it contains the configuration file. The common folder contains the page factory class. The data config contains the properties used across the project. The pages folder, where the page object model is being implemented. In our case, as we discussed above, we are dealing only with the home page and spend and save page. But you can have as many pages as needed under this package, depending on how many flows across how many pages you need to test. Next, we have the util package for reading the property files. Moving on the source main test folder, let's start with the test with the feature files right here, as you can see. Basically, they are translations of the use cases coming from the product. You do want to have them organized by area of concern, meaning in this case, having the home page separate from aspiration cards and spend and save cards. They basically contain scenarios to be tested, and the association with the running Java code is being done using the step definition, as you can see here. As the name implies, the step defs, as part of Cucumber framework, you need to have this step defs that contains the association between the feature files and the Java code when these tests are running. Basically, each of the statements in the feature file has a definition in the step definitions. The next Cucumber configuration package that contains the application hooks and the test runner. We will see more of this when looking at the code. Any questions? Okay, so next, let's look at the report generated by the Cucumber reporting framework. It contains the different features that got executed. You'll understand more when we look at the code and when we're going to run our example. You can dive deep into each feature if needed to find out the different specification for each feature test run, like run status, fail pass, duration, and so on. Also, it does provide some debugging information that can be helpful in quickly identifying what went wrong in most cases depending of your logging done. I want to add here, as I'm sure it was mentioned in previous classes, in general, it is really important for a QA engineer to report the results and escalate when needed, and it will be a benefit for you to bring this up in interview if you have the opportunity. So the libraries used for this project are Java 8, Selenium, Cucumber, WebDriver Manager that helps with managing the WebDriver automatically, Lombok for increased readability, Maven Cucumber reporting for reporting as we just saw. To be clear, though, this is important. In your assignments or your day-to-day work life, please use whatever tools that helps better in solving the problem at hand. In general, as advice, I would recommend being explicit as to why you picked one tool or framework over the other. As prerequisites for getting the most out of this example, I hope you are all aware about the GitHub link for the project. Do you all have this GitHub link? Please confirm. Do you have access to this GitHub? Do you want me to paste it somewhere?
Yes, I don't have access to this GitHub link at least.
You do not have access to this. Yeah. So can you in chat can you add your GitHub ID so we can make sure we can add you to have access to this after the class?
Yes,
do you all? Okay, awesome. Please add it in the chat. Badrish, anyone else? Do you all have access to this?
No, I don't have access.
Okay. So if just to add, in case you didn't share your GitHub email ID, please put it in chat or reach out to help desk to make sure the email ID is shared with iKey, and we'll make sure you all have access to this after the class. Sounds good? Okay, so
yes.
Thank you. So you also need to have to set up a workspace with your choice of IDE, like IntelliJ, Eclipse, Java SDK 8, if Maven to execute from command line if you want. Also, basic understanding of object-oriented programming language is needed. If not, a refresher may help in better understanding here. Also, a high-level understanding of BDD framework is needed that I covered briefly previous. Any questions so far before we move to the IDE? Okay, so let's move to the IDE. Okay. As you can see, the structure follows the same structure we talked about previously. But before moving, let's just quickly cover the POM XML to review the dependencies used in this project. So here we have Selenium, Cucumber for the BDD framework, WebDriver Manager right here, and Lombok right here. In case you don't know, it is used to minimize, remove boilerplate code and save time during the development. But in our case, we're using it to create getters. And we also have Maven Cucumber reporting for the reports that you will see the report live. Let's look at driver factory facade class. This library is an example of implementing three design patterns: singleton, factory, and facade. If you look how the driver is being instantiated, every time you call the get driver, it is returning the driver tied to the thread local, the current thread running. Internally, thread local is implementing the singleton pattern associated with each thread. In practice, as we discussed about this, in practice, if you want to use a singleton pattern only without thread local, when running tests on multiple threads, it is a headache and dangerous. The thread local creates a final variable per thread that is being returned using the get driver and makes sure you do get only one unique web driver for each thread. While this presentation does not focus on the thread local, I would recommend to dive deep into this concept that is being used in most programming languages. The next method, the set driver, implements the facade by the fact that it's hiding most of the web driver complexity away from the caller, which are the classes that are using the web driver. Basically, the caller does not know how the driver is being set, with what types of properties. It is just getting it and using it. Driver factory facade is being used in the page factory library to properly set up the driver right here. We are using, going back, we are using a local variable of the web driver to modify it per our needs. All the actions that we set in our set driver method will be associated by the get method to a single thread only. Potentially here you can add more things like headless, specifically here, or headed. You can potentially set a default driver if your use case needs it, restrict or add functionality available to your customers, and so on. The class driver factory facade serves as a factory as it could return any driver needed for the tests with the extra functionality. In our specific case, we are using the Chrome driver, as you can see in the configuration file right here. Now imagine not using these patterns, how difficult the implementation will be. For examples that come to mind, each test file will need to set up its own web driver with own configuration, which can lead to bugs or at least differences. Imagine not using singleton pattern for the driver and try to run a test that execute different actions on the web page that may end up using different drivers. I cannot even imagine this, so it will be a mess. Maybe not as obvious, but if you're not using the facade pattern, the problem potentially surfacing are not small. Imagine having to set all the properties for each test class. Also, why do you always need to know about the driver properties if you are just implementing on fixing a test? As you can see, facade hides some of the complexity away, and this usually makes our life easier and less prone to mistakes. And any questions so far? I do want to add that in case you all have to leave early, it's important for me for you to take a poll for us. So please let me know, and I'll trigger the poll before you leave. I would really appreciate that. So any questions before I move forward? Okay, next I want to talk about the common page factory. This class is implementing of the factory pattern which render the pages objects to the client. We instantiate the driver and the two pages we may need in our tests. We use Lombok right here to create getters. We set the browser per customer request using this, and using the getter to return the driver and pages when needed by the client. In our case, we are doing this in the configuration file that I will cover next right here. Let's go back to the page factory. So the page factory is hiding the complexity, singleton driver object, and the browser types involving construction of the page objects. Again, I want to bring up the consequence of not using a factory design pattern here. This will mean that for each test file, you'll need to create the pages you need, and at the very least will lead to increased code complexity and code duplication. Okay, so moving to the configuration. This is exposing all the configuration needed when running the tests. We set the browser to Chrome right here. We set the URL for later use, and we set the driver properties. The configuration is being expanded by the step definitions right here, top, right there. Okay, but we'll go back to the step definition, and we'll cover those explicitly. Next, let's look at the pages folder for examples of how we implement POM. By the way, it can be named whatever you want, as long as it is self-explanatory, and it is recommended to follow the tested website naming convention for ease of read. So we'll start with the homepage class, which is opened. As you can see, all the elements that we care about as they relate to the homepage are being created using locators. Really short, I hope you all know about locators, but locators provide a mechanism for identifying HTML elements on the page. As POM directs, these elements are not being created anywhere else. Also, they are being marked as private, so only actions in this class can use them. So if we need to do something to any element on the home page, like click, input text, make sure it is visible, and so on, it is recommended to have these action checks covered in the homepage class, and you can access it by like homepage.action after you import that homepage in the library where you're working on your tests. And the same applies for the spend and save page as well. So question for you all: what do you all think will be the drawbacks here for if we're not using POM? And I think we discussed about this. Anyone wants to try? Okay, so we will at the very least find the elements we care about when the test needs it, and also define the actions in the test. This will, again, at the very least, create quite a long and hard to read test, and usually it is an invitation for possible test failures. And I want to bring up maintenance. I mean, if you need to fix one action or an element locator in multiple library tests, that would be quite expensive. Next, let's look at the data config, at the config properties. This is a container. This is a container for all properties used across the projects. It can contain data for each environment you are running. As an example, for our purpose, we only have one property file that has data only for production, where this sample automation is running. But you can have Q&A properties in the case if that is a test environment you are using, or gamma or beta, that contains specific information for that specific environment. So let's look at the last SRC main Java, which is the util before we move to the test. In the config reader, we are reading the information stored in the config from here. In our case, we just create one instance of the property prop and use it every time exposed to the get application URL, because in our demonstration we just need the URL. So next up is the test folder. Over here, we'll work backwards from the feature file, starting with the homepage feature. As explained before, this is the like English language that is being used here, which in general are sentences paired with keywords that describes a test that actually is being run. Features right here is a keyword from the Cucumber library, same as scenario, given, when, and then. As they describe BDD. Feature represents the feature under test and is being used to group all the tests run by the feature level. What is being tested is covered by the scenario, and you already know about the given, when, then. One thing to note, all the sentences, expressions associated with given, when, then, they have a corresponding step in the step definition that explains exactly in Java code what is being done. Any changes you make in these sentences without an explicit change in the step definition will break the test. So let's look at each test step for this particular test to see what it means. So let's say when user hits the URL, what does that do? So in our case, we log in, hey, we are on the home page, we set the driver properties, and we like go to the URL is hit. And then we validate that user is navigating to the home page. So this is just we log in that we want to validate, and we assert that the homepage title exists, and we fail in case the homepage title is not displayed. And the next, validate the user is able to see the text associated with the aspiration bank card. So here we do a logging saying we are on that page and we're validating the aspiration bank card. We have a Boolean that says is it displayed or not, and we assert for the display and failure in case it's not. And the same for the aspiration plus bank card, we're doing the same thing. Next, let's go to the step definitions that we kind of navigate briefly. Here, the on-page steps and spend and save page steps implement the Java functionality, as I mentioned before, for each step in the test feature files over here. Any questions on this? Okay, so next, let's cover the test runner right here. This helps answering the question, how are these expressions in the feature files associated with the Java action? This is the role of a test runner file that needs to be created for any Cucumber project, where you define the mapping using the standard syntax. We give the feature location right here and make sure that the glue points to the step definition package. The plugin piece right here covers the reporting as we decide to generate the Cucumber JSON as well. The test runner method, again, it's a general syntax for Cucumber test-ng, where we specify that we want to run the tests in parallel. We do not do anything else specific here. Let's look at the application hooks really quick. This is nothing else but the actions that we need to take before running the tests and after. In our case, we are just making sure that quit driver happens first. This quit driver step is really important, as this exits the browser, ends the session, tabs, pop-ups, anything associated with the test run. So potential new tests can start without being affected by the previous run. We did not implement the test screenshot fail scenarios, as we're not using it for this presentation, for this demonstration. With this, I think we covered most of the things on this framework. Any questions as it relates to design patterns or this framework before we move forward? Okay, I really want to mention really short the README file that provides a solid start into the testing framework. So if you want to run this project locally, please look at the README first. Okay, so let's try to run this. First, let's delete the target folder to not have data from a previous run. Delete. And we'll run it using Maven test run. So it should start running. Let's see when we're going to see the driver being created. Still running. Okay, now the drivers are big. I'll show you the. So you see that it has multiple threads. So that in this case, the how many threads how many threads we're running is being done by the how many feature files we have. They're still running. Want to add that you can also run this from the terminal using Maven Test if you have Maven installed, but may not be the best way. Also, you see, this is for you to see that we're running the tests in parallel. It may take a bit for them to run. We should see the target folder back. Yes, it's back. As we wait for these to run, I want to mention again that reporting is really, really important for any automation framework. You want to make sure the results are easy to parse and meaningful. In case of failure, you generally want to see what went wrong so you can quickly fix what needs to be fixed, especially in the case of a test framework problem, or raise the problem so it can be at least triaged by the team. Let's see. That's why designing an efficient and easy to read test report is really, really important. We're still running. It might take a bit more. My Mac is a M1 chip, so it's some of the things are not yet made efficient for this type of chip yet. Should be short here to be done. Okay, so it looks like we had a successful run. Let's look at the report right here. Feature overview. Open in browser. Let's choose Chrome. Let's see. So here you see the report. You can see the summary for each of the features that we tested. And if you dive deep into one, you will see the before running the tests, all the steps that have been run. You see the output, the custom output when we run to the use case. And here you see the after, especially the quit drivers that is really important for us.
Want to become a software engineer at Google? You can, like thousands of our students. You just need to learn from those who've already cleared FANG interviews. At Interview Kickstart, our interview prep courses are developed and taught live by 150 plus instructors from Tier 1 companies like Google and Facebook. Our courses are tailored to help you crack software engineering domain interviews, including back-end, full stack, machine learning, embedded systems, data science, and more. To learn more, book your 3 webinar slot today